The types of samples you learned about in the first two sections of this tutorial were either purely random, a simple random sample, or random within predetermined strata. These are examples of probability samples. Probability samples use some probability mechanism to assign members to the sample. Two other types of probability samples in common use are cluster samples and systematic random samples. Cluster samples involve a two-stage sampling procedure. Cases are randomly selected to be interviewed from a naturally occurring group or cluster that was also selected by a random process. Say we want a sample of 30 high school juniors out of a class of 390. The juniors are divided more or less equally between 13 English classes or clusters. A cluster sample would randomly select some of the clusters, maybe 5 English classes, and then randomly select some individuals from each cluster. If we drew 6 students from each of 5 English classes, we'd have a cluster sample of 30 juniors. Is this a simple random sample? Of course not. Not all conceivable groups of 30 students from the class are possible. Is there a random process? Yes. You aren't deciding which individuals go into each cluster, and each cluster is equally likely to be in the sample. A systematic random sample is a good alternative to a random sample. It's often easier to do than a purely random sample, and it may well give a sample more representative of a population than a pure random sample. To conduct a systematic random sample, you first order your population in some way, say alphabetically. Then you systematically sample the population. Since a systematic random sample involves ordering a population, it's important that the ordering doesn't affect the outcome of the survey. Let's go back to our high school juniors example to see how this works. We've alphabetized our population of 390 juniors and want a sample of 30. 30 goes into 390 exactly 13 times. Convenient, huh? So we know we need to select about 1/13 of the class to get 30 cases. We now randomly select one of the first 13 individuals on the list. This is why it's still considered a probability sample. Then we select every 13th person on the list after the first one for our sample of 30. Systematic random samples are very common in situations such as this. They can give you a sample quite representative of a population. A couple of other types of samples can also be used, though under most circumstances you'd want to avoid them. They're convenient samples and self-selected samples. A convenient sample is just what it sounds like. You can get it conveniently without any random process. Still trying to get our sample of 30 juniors, we might simply ask Mr. Rodman if we could interview the 30 members of his U.S. history class. It's convenient, it's easy, and it's not random, and we have no way of knowing if it's representative or not. If we were sure that students were assigned to U.S. history classes in a purely random fashion, and if we randomly selected one of the U.S. history classes to survey, this might qualify as a cluster sample. But because we directly chose who would be interviewed, the results are highly suspect. Anytime a human is involved in choosing subjects without using some random process, there will probably be bias.